All right, today we want to solve a question that comes from the Mathematical Applications for the Management, Life, and Social Sciences, 12th edition by Harsbarger and Reynolds. This is from Chapter 4, Section 3, Exercise 21 on page 286. We are trying to maximize f equals 2x plus 3y, subject to the constraints x plus 2y is less than or equal to 10, and x plus y is less than or equal to 7. We also have the basic constraints of x has to be greater than or equal to 0, and y has to be greater than or equal to 0. As well, so those are also part of this, and we're supposed to use the simplex method. So to use the simplex method, we're going to introduce a couple of slack variables, turning these inequalities into equalities. S would be, I have a limit of 10 of some resources, and S would be whatever I'm not using of that. And I have another resource that has a limit of 7, and T would represent however much of that I'm not using. And so I'm going to put those into the simplex matrix or tableau. And I need a column for each of my variables. I'm going to have an X, I've got Y, and S, T, F, and ST and F are the values there. And so I'm going to take each of these equations and put them into this matrix, writing down the coefficients. So 1, 2, 1, there's no T's, there's no F's, and it's equal to 10 there. And the second constraint equation has 1x, 1y, no s's, 1t, no f's, and it totals up to 7. And then for the objective function, I need to put everything on the same side of the equal sign. I want to shift all the variables over to the same side. So it's the same general format as the other constraint equations, with all the variables equal to a number. And when I do that, the x becomes negative, the 2 becomes negative, and the 3y becomes a negative 3y. So we end up with negatives down here. We're going to select our pivot column. It's the one with the largest negative. And then find our pivot row. I'm going to look at that column. I'm going to take the values in the column and divide down here at the very end. Take 7 divided by 1. It gives me 7. 10 divided by 2 is 5. And I want the smaller of those two values. So that would be the 5. So our pivot would be the 2. What I want to do is I want to turn the 2 into a 1 and then use that 1 to create zeros below that row. So I'm going to start by just doing 1/2 times row 1 and put it into row 1 spot. Divide row 1, everything in row 1 by 2. And 1, 1, 0, 1, 0, 7. The other two rows stay the same. All right, and now what I want to do is I want to create zeros. I'm going to use that 1 to create zeros in the other spots of that column. I want to turn the 1 below it and the -3 into zeros. I can do that with 2 row operations. I can take -1 times row 1, add it to row 2 and put it into row 2 spot. And I'm going to do 3 times row 1 plus row 3, put it into row 3 spot. You have to use that pivot row to create the zeros in the simplex method. You have to use that pivot row. So -1, well, the first row is going to stay the same. I'm going to leave it the same. I'm not changing it, although I am kind of doing these operations with it. So I'm going to take -1 times what's in row 1 and add it to what's in row 2. So I'm going to have a -1/2 and a +1. They will add together to give you +1. A -1 plus 1 would give us 0. -1/2 plus 0 is -1/2. -0 plus 1 remains 1. 0 plus 0 is 0. -5 plus 7 gives us 2 there. And then for the third operation, 3 times row 1 plus row 3, 3 halves, 3 times a half, 3 halves plus negative 2, that would give us negative 1/2. Negative 3/2 is 1.5. If you add 1.5 with a negative 2, you get a positive or negative 1/2. 0 for the next one. 3 times 1 plus negative 3 is 0. 3/2 plus 0 is 3/2. 3 times 0 plus 0 is 0. 3 times 0 plus 1 is 1. 3 times 5 is 15. Plus 0 stays 15. So I'm getting closer, but I'm not there yet. I've got a negative here in the bottom row still, so I have to do another pivot. I've got to take 2 and divide it by 1/2. I need to divide it by 1/2. Remember, that's flip over and multiply. So that's going to be 2 divided by 1/2 is 4. And 5 divided by 1/2 is going to give us 10 when you do that division there. You got to divide by a half. You got to see how many halves can you get out of 5. Well, you can, if you have 5 pies and you cut them into halves, you're going to have 10 slices altogether, 10 half pies there. All right, so that's our pivot is going to be this 1/2 in the second row. I'm going to take the smaller of the two values. So I'm going to take 2 times row 2, put it back into row 2 spot. I want to turn that 1/2 into a 1. You know what? Actually, I'm going to wait on that. Everything else is 1/2, so I'm just going to work with it. I'm going to take row 2 plus row 3, put it into row 3 spot. And I'm going to take minus 1 times row 2 plus row 1, put it into row 1 spot. Let's do those two operations first. Let's create our zeros first. Again, I have to keep working with this second row. To do that, I need to do something to row 2 and to combine it to the others to make the zeros, to do the simplex method correctly. So minus 1/2, minus 1 times row 2 plus row 1, that should be 0. Negative 1 times 0 plus 1 stays 1. Negative 1/2 times negative 1 would be positive 1/2. Plus 2 gives you a positive, or plus 1/2 gives you positive 1. Negative 1 plus 0 is negative 1. 0 plus 0 is 0. Negative 2 plus 5 gives me 3. And then row 2 plus row 3. So I just can add there 1/2 and negative 1/2 is 0. 0 plus 0 is 0. 1/2 and 3/2. Add those together. Negative 1/2 and negative 3/2 will add together to give you 1. 0 plus 1 is 1. 0 plus 1 is 1. 2 plus 15 gives us 17. And so we are almost there. Whoops, I got to fix this pivot. I need to turn this pivot into a 1. So let's do 2 times row 2. 1/2 times 2 will give us 2. Put it into row 2 spot. Top row stays the same. Middle row, you're multiplying everything by 2. And the bottom row is going to stay the same. And so now we look for our solution. We've got our pivots. We've got our 1s and 0s everywhere. My x column was here. Lines up with the 4. The 1 lines up with the 4, so x equals 4. This was the y column. It looks nice. The 1 lines up with the 3, so y equals 3. Our s column is full of messy numbers. I'm going to set equal to 0. Our t column is also full of messy numbers. I'm going to set it equal to 0. And f should be 17. So our maximum value we can get is 17 for f when x equals 4 and y equals 3.